Hello, I have made a Manim tool which I think is pretty handy and I would like to demonstrate its usefulness. So it's called TransformByGlyphMap. It's a subclass of animation group. It's for transforming text objects into other text objects by giving them a so-called glyph map, which is just a way of telling it what glyph indices should go to what other glyph indices. So for example, let's say I want to transform this text object into this text object. I use this syntax here. I need to know what indices are which. So before I know that, I would have to add them to the scene and use index labels and everything like that. But with this, if you just give it a blank glyph map like that, then when you run it, you will find that it shows you exactly the indices all on its own. So that's pretty handy. And now using this, I can see that I want index 16 to come on down in here to become index 4 and index 13. So that's what I'm going to write in here. 16 should become 4 and 13, like that. And now I also see that these parentheses aren't going to get mapped to anything down here, so I need to tell them what to do. I'm just going to have them disappear. So 0 and 15 should become nothing. So that would be 0 and 15 will become nothing, like that. And so now if we run that, we'll see that this, we'll see it do exactly that. That 3 is going to come into those 3s, and then everybody else just sort of stays like that. Now the way I did it, that 3 is kind of weird how it's like splitting in 2 like that. So another way that we could do it is instead do it like this, where you have one of them go into a 4, and then you have another one go into a 13. If you do it this way, then now it's going to make a copy of the 3, and each of those 3s are going to individually go inside like that. So you can see it looks a little bit different. So yeah, that is the idea behind TransformByGlyphMap. Let me show you another example. This time it's for doing this sequence of things. You can see what's going on here. This time I'm going to keep them arranged in a V group, and I'm just going to use the parameter fromCopy to keep all of them there the whole time. So we'll see what this one looks like. Like that, and then like that, and then like that. So yeah, so for each of those, like this first one for example, I just took those indices and sent it to those indices, and then also took those indices and sent it to those indices. So that's why it made like a copy of the x plus 4, and those came down like that. And then I sent the x to the x and the plus 3 to the plus 3, and I sent those first pair of parentheses to just fade out, so you can see how those just disappear as it moves down. And then the next one, I distribute those things across just like that, and then finally I just take all the indices of those middle 2 terms and turn it into the indices of just the 7x, which is why everybody else just gets sent to where they ought to go. So yeah, this is the idea behind TransformByGlyphMap. I think it's a pretty convenient way to work with text objects. So yeah, here is one more example of deriving the quadratic formula, which I haven't worked out yet. I've just done it, I've just made all the framework here, so you can see what it is like to actually work with this. So, starting at the top here, when it hits this first one, it's going to see that we're giving it blank ones, which means we want it to show us the indices. So that's what it's going to do. You can also trigger that by passing show indices equals true, but you can do it that way too by just giving it a blank section of a glyph map. And so I can see here that I want 6 and 7 to become 7 and 8. I want 8 to become 6, and I want 9 to disappear. So 6 and 7 should become 7 and 8. I want 8 to become 6, and I want 9 to disappear. So then, assuming that is correct, What the hell just happened there? That's not what I wanted at all, dude. I'll put this here. I gotta do that so that it doesn't try to continue to do all the other ones after that, which I already wrote out. And so now we can see that the plus C becomes a minus C, perfect. And then now it's going to trigger the next one, which is going to show me the indices of what I want over here. Okay, so now I want this A to become these two A's. I want these fraction bars to kind of just appear out of nowhere. And then everybody else I want to stay the same. So this x squared, this plus, this B should just move right up here like that. This C should just move right up here like that. And all of that's going to happen automatically as long as I don't say otherwise. So, yeah, so 0 should become 5 and 11. 0 should become 5 and 11. And 4 and 10 should just come out of nowhere. So nothing should become 4 and 10, like that. And hopefully we'll observe that that does exactly what we're looking for. That A is just gonna, uh-oh. So it didn't work. There was some kind of problem. It's because, so let's read the thing. Oh, my bad. It's because I left a blank thing, so it's still trying to do that. My bad. Okay, so now this should work properly. And also let me move this to the next one so that we can see the next one too. So if the unmentioned indices don't have the same length, then it will trigger that because it needs them to have the same length for it to know what to send where. Forgot to close that. But you can also trigger that manually by leaving a blank glyph map or by using the show indices parameter. Okay, so let's take a second look here. We see how that A becomes both of these A's, which is just right. We can see how the B and C move up, and then those fraction bars fade in. So that's exactly what I want. Okay, so next we want to add this complete the square term here. So that's 7 through 14, and that's 20 through 27. They just have to come in out of nowhere. So we're going to say 7 through 14. You can type them all out, but you can also use like range or something. I made a little function called IR, which I just typed 7 to 14 like that. Oh, and I messed it up though. It's not supposed to go there. It's where we're going to. We're making that, so that has to come from nothing. So it has to look like that. And then also coming from nothing is 20 through 27. 20 through 27. So that should do the trick there. And then we'll go ahead and look at the next one while we're at it. Let's see if that looks correct. And so when those fade in, everybody else should just slide to the appropriate new location. Oh, son of a bitch. It didn't work. I screwed it up. Oh, I did the same damn thing. I forgot. I don't want to have that there. That's supposed to be convenient, and it's being more inconvenient than anything. Alright, let's try that one more time. We'll see that this fades in like that. So they fade in and everybody else moves to the side like that. Great. Okay, and then the next thing is this. So now, what I'm doing this time is I'm just swapping these around. So I'm going to turn 21 through 27 into 16 through 22. So 21 through 27 needs to become 16 through 22. And then 16 through 19 should become 23 through 26. So 16 through 19 should become 23 to 26, like that. And then finally this plus sign is got nowhere to go, so that 20 is just going to disappear like that. Okay. Let's give that a go. Uh-oh. It's saying mismatched number there, so something's probably not right. Oh no, it worked. Okay, great. So those two swap. That plus is getting faded out. That's correct. So it must have been talking about the next one. So the next one, all I'm doing is I'm taking this 2 and I'm distributing it into these parentheses here. So this 2 needs to go here, and it also needs to go here, and then it also needs to combine with that 2 to become 4. So it needs to go 3 places. It needs to go to here, and then also to here, and then also to there. So I'm going to do that 3 different times. 22 goes to 17. 22 goes to 17. 22 goes to 21. And then 22 goes to 22 and 19 are going to combine to become 19. Right. And then hopefully we didn't leave. Oh yeah, and then we got to do something about these parentheses. These parentheses just got to disappear. So 16 and 21. 16 and 21 are just going to disappear like that. All right, and hopefully that is, everything's good there. Whoops, I forgot I have to close that. I also have to do this, so worked out. Okay, so now we'll see that that 2 becomes all of those, and also those parentheses fade out just like that. And then everybody else slides to the appropriate location now that those parentheses are no longer taking up all that space. Next, it looks like I'm adding stuff to this fraction to give them the same denominator. So this numerator's got to gain a 4a, so that 23 and 24 got to come in out of nowhere. So I'll say 23 and 24 got to come in out of nowhere. And then in the denominator, 27 and 29 got to come in out of nowhere. So I could do those separately. Oh, again, I'm putting those in the wrong place. 23, 24. I'll do them in the same one. It doesn't actually matter because these all get split anyway. 27 and 29. Right, and that's it. Everybody else is going to stay the same. It's just those people fading in. So I can get rid of these. And that should hopefully work on the first try. We will find out. And go. So now we see that the C and the A are good. Notice how that fraction bar just automatically changes size and everybody else switches over. I just think that's so gorgeous and cool. And then they all fade in. And then now it's showing us the next one. So the next one is, this numerator is going to become this numerator. This subtraction is going to become this subtraction. This numerator is going to become this numerator. These fraction bars got to merge together, and then these denominators got to merge together. So this one's going to be a complicated one. We have a lot of things we got to do this time. Okay, so I don't actually have to mention 16 and 17 because that's still going to be part of this whole sequence of glyphs that don't get changed. So technically, I don't have to mention that, but I could if I want to. It wouldn't change anything, but I'll leave it out just to demonstrate that you don't have to because the whole thing is so far untouched. I do have to mention this, 23, 24, 25 has to become 19, 20, 21. Has to become 19, 20, 21. This subtraction has to become that subtraction, so 22 has to become 18. 18 and 26 have to combine together to become 22. 18 and 26 have to combine together to become 22. And then these two guys, 19, 20, 21, is going to become 23, 24, 25. 19, 20, 21 is going to be 23, 24, 25. And then actually, these three as well. 27, 28, 29 are also going to become that. 27, 28, 29 are also going to become that. So yeah, hopefully that will work. Let's find out. So now, you see how those numerators stay, the subtraction comes up, the fraction bars combine, and the denominators combine. I don't particularly like how that right fraction bar seems to be fading as it goes. I guess that's one of those weird transform behaviors. I like it more like how the denominators stay their full opacity until they are overlaid like that. So I want the fraction bars to do the same thing. So I'll use the same trick that I did with the fraction bars, which is to do those separately. So I'll just do that as a separate thing, like that. Perfect. And so now we should see a difference there, that they both stay their full opacity. That's right. So great. Okay, and then now the next one. Yeah, so the next one, we're taking this entire thing and we're turning it into that. Now, you know, lots of options here. One option would be to like take this x and put it there, and this x and put it there, and maybe put these pluses here, maybe put these b's here, or something like that. You can totally do that. That is 100% totally cool. But I think this time I'm just going to go ahead and say, I'm just going to do that all as one single V group. So everybody from 0 to 14 and everybody from 0 to 8. Because algebraically, that's really what it is. It's like this entire thing is really this entire thing. It wouldn't really be, it would be questionably meaningful to do it a different way. But I don't know, maybe I could, maybe it would be cool to do it that way. But yeah, but I'll just leave it like that for now. And you can see the results of that. If I do it like that, it's just going to do it all as one big V group. And so it's just going to smoosh it all together, you know, whatever way it decides. Oops, I forgot to close that. That's okay. Uh-oh. That's weird. Oh, it's because I put the return... Oh wait, my bad. No, that's not weird at all. It did it. Never mind, that's not weird at all. So yeah, so you can see just as one big thing, it smooshed it all together. Looks like that 2 survived, which I rather wish it didn't. So if I wanted to, I could get in there and like say who goes to what. But then the next thing I gotta do is these parentheses gotta drop, and this 2's gotta become the 7, 8, and 9. A weird thing about square roots is that they actually consist of 2 glyphs. So this 8's gotta become 7, 8, 9. This 8's gotta become 7, 8, and 9. And then the parentheses gotta drop. So 0, 7, 0, and 7's gotta just drop. And then we'll leave that. See, maybe it would be nice to do this a little nicer, honestly. Even if it's not like algebraically meaningful or whatever. Maybe it would. Okay, so yeah, so you see how those parentheses just drop, and that becomes a square root. Gorgeous. Okay, so now next thing, this square root, the 8 and 9, is going to get split into the 8, 9, 17, 18. So having played around with this before, I know that if I just do 8, 9 sent to 8, 9, 17, 18, it's going to look kind of ugly because it doesn't, it's like this part of the square root is going to get sent to these two, and then this part of the square root is going to get sent to these two. So what I've learned is actually I'm going to send 8 to 8 and 17, and 9 to 9 and 18. And that looks really nice. 8 to 8 and 17, and 9 to 9 and 18. And I think that is a good way of doing it. So this time, that goes to that, and gorgeous, that skips down just like that. That's exactly what I want. And then now next thing is this square root has got to become this. So I think I'm just going to fade them out and transform that too, honestly. 17, 18 is just going to get faded out. That 4 is going to become a 2. And 20 and 21 are just going to become 18. Like that. And let's see how that looks. Ah, fucker. Oh. Uh-oh, looks like I accidentally did 2 things in the same line there. I didn't want to do that. What the heck? That was not supposed to be over there yet. Uh-oh, looks like I need one more line here. Okay. Okay. Oh, you dummy. Alright, let's try that again. So now that becomes that. This is exactly what I want. And then now finally, for the last subtraction, we see that 1, 2, 3, 4, 5 has to become 2, 3, 4, 5, 6. So 1 to 5 has to become 2 to 6. I don't understand how I did that. I don't know. I probably am missing something. Okay, 1 to 5 has to become 2 to 6, and that's it, actually. And then hopefully that does it. Actually, that was completely pointless. That's the end of the animation. Gorgeous. And then the last one is this. And so what are we going to do here? -2, 3, that's all fine. 4 should become 16. No, 4 and 16 should become 13. And I'll use the same trick from the other fraction thing to do it like that. And then 5 and 6 should become 14 and 15. And then almost the same thing for this last one. 17 and 18 should become 14 and 15. And I think that should do it. So with that in mind, I'll give it a one of those. But didn't I just add a thing? Am I crazy? What? Didn't I just add a line? Like, how is it not? Oh, I guess that does go to 13. Okay. My bad. Whoops, I forgot to close it. Let's try it again. And so we subtract that over. Beautiful. And there it is. That is the quadratic formula. I meant to do circumscribe, but indicate's fine too. Okay, cool. So there you go. So that is a demonstration of this handy tool. I think I'm gonna go in here and actually do this a little different. Let's see. So if you want to change it, you can give it a blank thing, but you can also say show indices true, and then it will override whatever else it was going to do and do this instead. So now it's going to show me the indices for that step. Even though the unmentioned indices are of matched length, it's not going to do it. It's going to show me this. Okay, so now let's see what do we want to do here. Let's say the x's go to the x, so let's say 0 and 6 go to 1. This is going to be so whack. But let's just see if this is any good. The 2 and the 7 go to 2. Whoops. The B over A. Okay, so 3, 4, 5 should go to 3, 4, 6. And then the A should go to the A. So 5, so 9, 10, 11, 12 should go to 3, 4, 5, 6. Oh. Nine, 10, 11, 12 should go to 3, 4, 5, 6, like that. And then let's send 1 and 14 to 8. And then we'll send 8 to 0 and 13 to 7. Oh, there we go. And is that everybody? I think that's everybody. I guess we'll find out. We'll try to run it and we'll see what it looks like. Looks like it was good. So yeah. So if you stopped watching earlier, that is probably for the best. This went on really long, but if you wanted to see this whole thing in action, I think it's pretty cool how quickly you can make a complicated sequence of algebra like this. You know, like the old way would take so long. Yeah, that's honestly pretty gorgeous, I gotta say. That's better than the way it was. I'm happy with that. And then that. And then we'll simplify the right-hand side. That becomes that. That becomes that. That subtracts over there. And then those combine together. And then, boom, there you have the quadratic formula. So yeah, I think that's pretty cool, I gotta say. So yep, hopefully somebody else finds this cool or useful. I will definitely be making good use of this tool for making complicated LaTeX animations, because holy moly, that is a whole lot easier than what I used to do, in my opinion. Okay, bye-bye.